So we're calculating the t-score by calculating the difference and dividing it by the standard error of the mean. It's the same principle that you have with the SAT statistic, but now you're calculating t-score. The difference is the calculation of the standard deviation, and that you have the standard deviation estimated from your sample and not given from the population. Yes, Sivan.
How accurate is the estimate that we make from the report? That estimate is not accurate.
Well, it's not super accurate, but it means to kind of accurate. That was a philosophical question which I'm not sure I can answer. But then if you look, so you remember from the SAT distribution, from normal distribution, we're assuming a critical value, leaving 5%, 2.5% on each side on each side of 1.96. What this manipulation essentially does, assuming the degrees of freedom rather than the actual sample size, it basically gives you an estimate beyond which your hypothesis test would be significantly different statistically, and only at a sample size of, and if you go all the way down, only at the sample size of 500, you're basically with your hypothesis test again at an alpha of 1.96. So the larger your sample, the more it qualifies as a population, so to say. So statisticians recommend you get away with using a SAT statistics at a sample greater than 30, but there are still differences, right? But it's just they're marginal differences. They don't make in the greater scheme of things not that much of a difference. Therefore, but bluntly spoken, you can use a confidence interval. If you estimate a 95% confidence interval using the critical value multiplied by the standard error of the mean, you can use a 1.96 after a sample size of 30. So how accurate is it? I couldn't quantify, to be honest, but there is some level of difference that is quite strong. So, but this is why it's important that you kind of use degrees of freedom here. So you use a t-score table rather than a SAT score table. And the SAT score table has a different kind of interpretation in the greater arm of schemes, because you basically have a population standard deviation and you know more about your population than you know of your sample. So you're trying to estimate it based on that little sample that you have. And you estimate that this is just an estimate, and you try to kind of like use it to extrapolate to your population. I think that's a fair way to express it. Yeah, thank you. A good question, very good question. Okay, so t-score. So we're estimating. Now the standard deviation. We're using the standard deviation to divide it by the square root of the n to get to our t-score, and finding critical values from our t-score table, and then comparing it to a reference value or the population mean. Under the null hypothesis that mu1 equals mu2, or our sample mean equals our population mean, or for an independent sample t-test that the sample means of both samples are identical. Whereas under the research hypothesis, we assume a difference. Under a two-tailed hypothesis, under a one-tailed test, we assume a directional difference. So we think that sample 2 is larger than sample 1, or sample 2 is smaller than sample 1. We are then calculating t-scores. We're testing this against critical values, which are indicating these outer bounds, which are essentially identical with our 95% confidence interval. If our t-score exceeds this critical value, we are rejecting our null hypothesis that this mean is not significantly different from our population mean or reference value. Confidence intervals are calculated by taking the standard error of the mean, multiplying it by our critical value, and subtracting it from the mean or adding it to the mean. In the context of a paired sample t-test, this is a little bit of a different interpretation, because you're calculating, because your sample becomes your difference. So when you go for a paired sample t-test, you basically have a before and after condition where you calculate the difference. So you're testing essentially your difference against a null hypothesis of 0, where you assume that the difference from before to after is 0. So the calculation here is your difference minus 0, which essentially, when calculating, so here it's 0.2, that's our difference. That was the example of the article involving physical violence, whether you associate with the person, the reader of that article, associated it with mental health. If he or she read it directly and was asked directly after reading that article, he or she was less likely to associate with mental health, whereas when he or she read it 2 weeks after, that individual was more likely to associate with mental health. So this difference is 0.2, and we calculated that in that class. And we're subtracting here our null hypothesis of 0. That means that we're hypothesizing that there was no change. So this change of 0, we're subtracting from our difference. If we have an expected change, we would subtract this expected change from our observed difference. We're dividing it then by a standard error of the mean, and we derive a t-score. What's different for the confidence intervals here is that when you calculate the confidence interval for difference, and you have essentially a difference that includes 0. So here you have 0.2 to a 0.03 difference and a 0.37 difference. If this difference does not include 0, you actually have here an hypothesis test that there was significant change, because the 0 is not contained in the 95% confidence interval. So you automatically have a sample of differences between before and after that is exceeding your null hypothesis value of 0. Okay? So that's the paired sample t-test. Okay. Cohen's d. Sharon. Hi. What is Cohen's d? What is it? Cohen's d. So Cohen's d is a marker of the effect size, right? You remember that? Yeah. How is it calculated? No? Juliana, can you help? No. But Shiva, you have a, do you know? Cohen's d. Cohen's d. The effect size?
Is it the mean of the divided by
Standard deviation, yes. Not by the standard error, but divided by the standard deviation. Based on your surprised look, I don't think. Okay.
I don't understand what you said.
Okay, again, and this is why this review is important in my head. So again, we're calculating a t by calculating the difference, and we're dividing it by the standard error of the mean to get to a t. But dividing it by the standard deviation gets us an effect size that is focused on the difference rather than the standard error of the mean. And we're taking out of this equation, what are we taking out? Of the standard error rather than the standard error, because the standard error includes the sample size, right? And the sample size will automatically affect your standard error of the mean, and your standard error of the mean would get smaller. As a consequence, you're dividing your difference by a smaller value that is smaller because of the sample size. Therefore, your t is going to be greater. By calculating by the standard deviation, you take the effect of the sample size out. And then you compare this effect size to your conventions, which are Cohen's conventions, which is 0.3 to 0.5 is a small effect, 0.5 to 0.8 is a medium-sized effect, and greater than 0.8 is a large effect. Good. All right, thank you. Confidence intervals. So in principle, all three t-tests that we discussed, single sample t-test, paired sample t-test, and independent sample t-tests are using the same principle. You're basically calculating a difference and you're subtracting from this difference your null hypothesis, which for paired sample t-test, it's 0. For an independent sample t-test, it's mean 1 minus mean 2 minus an assumed difference of 0. And this is illustrated in this slide. So we're calculating here the difference. Where is this calculated here? So we're calculating a difference between mean x, so mean sample 1, minus mean sample 2, minus an assumed difference, an expected difference, which under our null hypothesis is 0. Because we null hypothesized that sample 1 and sample 2 is identical. If that is identical, this difference has to be 0. So this term is going to be 0. So it's mx minus my minus 0. If we would expect a difference, and we're testing it against an expected difference, which you can also do, we would have here a different value. We would have here the expected difference rather than 0. But for our example here, we have an expected difference of 0 and our hypothesis difference of 0. And we basically get to mean x minus my, or mean y, divided by our standard error of the mean, gets us the t. And then we compare it against the critical value. Yes?
We always assume that it's mostly going to be 0.
Excuse me?
If you see the step one just t equals m, but we take away the null hypothesis, so we should just assume that it's going to be 0.
You will, in the practice course, there's no expected difference. So you can always assume this is going to be 0. So this is the formula you want to deal with. But hypothetically, if you would expect a difference, that's where you would enter it. That's where you would add it. Okay, but good question. Thank you. Good. So what else? Yeah, know how to report findings. So this is the APA standard. You have a t-score for a certain degree of freedom, and you state your t-score after an equal sign. You indicate your observed p-value, that your difference is the probability of your difference being only due to random sampling error or pure chance here after a comma. So this is your p-value. So since you've seen on the t-score table, it's basically an increment and only statistical software. No, well, you could calculate it by hand. Obviously, you can. It's actually not that complicated, but we're not doing it. You will get away by just stating it's smaller than a certain critical value of alpha that you're willing to accept. Again, the critical value alpha. Let's get back to that maybe. Just a second more. Tally is Sarah knows, but Sarah, what is an alpha? Yeah, thank you. I have Sivan. Well, you said something too.
It's like something to determine whether your value is significant.
Correct. It's your critical value determines your alpha. And in the greater scheme of things, it's an error that you're willing to accept, right? Which error?
Well, isn't there a few numbers?
Yeah, there's a.
It's less than 0.8.
If it's smaller than 0.05 or 5%, yeah.
Oh, I was thinking about whether it's a large, small, medium.
Oh, that's the Cohen's d. That's the effect size. That's the effect size.
So if it's less than 0.05 and greater than 0.
yes, it's always greater than 0. It can't be smaller than 0. Yeah, it's never 0. But I think the question is, you remember type 1 and type 2 error? So the alpha is the type 1 error. This is where you reject something that you shouldn't have rejected, right? And what is the type 2 error? Yes, exactly. Yeah. Okay, let's not, well, opens a lot of other questions, but let's actually get going. Let's do some calculations. We only have 30 minutes left. So it's also when you have an alpha, you're rejecting something that you shouldn't have rejected. That risk, that type 1 error rate that you're willing to accept should be lower than 5% if you set it at 5%. So that's your risk that you rejected something you shouldn't have rejected. The opposite is that you don't reject something that you should have rejected. That's a beta or a type 2 error.
You asked which is better?
It's called beta, yeah.
Oh.
Alpha and beta. If you're rejecting something, if you don't reject something that you should have rejected, 1 minus beta is your statistical power. And that statistical power you need to quantify in the knowledge of your effect size to estimate the sample size you need to study a certain situation with, to make a conclusion based on solid grounds with sufficient adequate statistical power. Okay. So, but let's jump into practice lab 3 now. 3. And so we have 3 examples in an Excel spreadsheet. We need now the practice lab 3 solution code from the canvas. We need that spreadsheet that is to be downloaded from practice lab. The deliverable for this practice lab is yes.
Mine doesn't say difference.
Yes, but it will soon because we're calculating the difference. Okay, that's a remnant from previous class.
Oh, yeah,
There's 3 things on the bottom.
Yeah, okay, good. Yes, the 3 things on the bottom are 3 different worksheets. So we have 3 different worksheets to solve, and these are going to be super simple, super fast. So we have 8 scores of 8 different students. We have an exam 1 and an exam 2. What tests do you think we're going to be doing? The one that we did yesterday. So yesterday, I don't know what test you did yesterday. Yeah, so that is also wrong. Okay, no, it's exam 1 and 2 from 8 students. What's the independent variable?
Two-tailed.
Two-tailed, yes, correct. What is the independent variable?
Oh,
Yes, we do an we do a paired sample data. Thank you, Siva. So the independent variable is here time point of exam, right? Whatever happened between the exam, you studied more material, you learned more material, the material for the test is different, but the independent variable is here, more specifically, is actually exam. That's your independent variable. Or time. You name it, right? It's like it depends on the research question, right? It's, you will need to understand the research question. If you say like, so there were 2 exams, and in between 1 and 2, I had tutoring, and then I did better on the second one. Then it would be time and tutoring. That's your independent variable. But here in this context, we don't know. It's 2 different exam scores. Students did different. So we see differences that are greater than 0. We're calculating exam 2 score minus exam 1 score. We're just calculating the difference. We are now in the next step. We're calculating the average by basically building with the average function at an average. So that's 1.25 average for all 8 differences.
Wait.
Hmm?
So how'd you get all the differences?
So we're calculating the differences by calculating exam 2 minus exam 1. Yes.
It's possible to explain it, but how do we know here to not put in a dollar sign?
Because we're dragging it all the way down and you want it to shift down, right?
Yeah.
And if you put the dollar sign, it will lock it in.
So if I put a dollar sign, would it give me minus the right?
It would give you, if you lock in this cell, it will basically subtract all these on exam 1 from that first exam. So you're locking in one cell as the reference cell. Good. Okay. Once we have this difference and this average difference, we need next a variability, right? We need variabilities to determine whether this is a significant difference in the average. So we are starting off with paired samples t-statistics. Good. So this will be done. So we have an alpha of 5%. Alpha is 5%. We have, what's our critical value? We have a degree of freedom of 7, and we have a p-value of 5%. Exactly. As Emma pointed out earlier, it's 2.36. Good job. So we have a critical value of 2.36, and now next we need our t. And the t is easily calculated by calculating this t-score by, we have a difference of 1.25 minus a null hypothesized value, which is 0. We're assuming there was no difference, divided by a standard error of the mean, which we don't have yet, right? So we're taking any random value 2 cells below. Now we're calculating standard deviation, that is STDEF of these differences. And now we need an SEM, which is essentially this divided by this.
You see about the 5 point. Can you just click on the SD?
Okay. I'm back. Okay, so we need 3 different components to calculate this t-score. We need a standard deviation, and we need a standard error of the mean, right? The standard deviation is calculated as STDEF of these differences. STDEF, C4 to C11. Gets you the standard deviation. Sure. Yeah?
Then how do you do the next?
Now we need the standard error of the mean next. I'm pressing enter. So standard error of the mean is now our, is now our standard deviation divided by the square root of the sample size. Yes. STDEF.
Mention STDEF P, should I go to the P?
Yes, now you can delete the P. So the P is a population standard deviation, which we don't use anymore. That was the reason why I didn't want you to use that function, because now you're no more STDEF-P. That's a very specific function that you will not use very often. And you will by default always use STDEF, which is a sample standard deviation. The STDEF.P was not meant to be used, but some of you used it. It shouldn't have been used. But yeah, whatever. So essentially, we're calculating our standard deviation, which is a sample standard deviation, and we are now next calculating the standard error of the mean, which is the standard deviation divided by the square root of 8, or the count of all your differences. Okay. So, and now our T is 0.62. Yes.
Here's the SDN.
Yep.
Oh, wait. Mine's not coming up. Mine's just like, yeah.
Go through all the steps again.
How do you get the 1.5?
You do 1.25 divided by the standard error of the mean.
That's your problem.
That is your T. This one is the average of this. Now you need to do the average of all of these. So this is now our 0.62 t-score. Since what do we see when we look at the critical value? It's smaller, right? Since it's smaller, we're not rejecting the null hypothesis. Good. So now if we go to bullet point B, we're calculating now a 95% CI. So for this, we need a lower limit and an upper limit. So as we know, the lower limit is our mean difference minus the critical value multiplied by the standard error of the mean, right? Comes to a lower limit of minus 3.5. Sure. Yep.
Yeah.
So now the upper limit is calculated by mean difference plus 2.36 multiplied by the standard error of the mean. 5 point.
You press on that again.
Yep. Okay. So these are our 95% CI limits. And now calculating the effect size is easy. We know that the effect size is calculated in the same way as the T, but instead of the standard error of the mean, we're using now the standard deviation. So it's 1.25 divided by the standard deviation. Gives us an effect size of 0.22. Okay? Simple. Good. Now we open R. Love the excitement. Okay. Okay. So we're going now in R. We all open this in R Studio. We're running line 2. Oops. Control Enter will run line 2. Yeah, that's not what you want. You need the tab. Look, if you have here, you need to first run RM. There's a tab that will allow you to click on the script, practice lab 3.
So do you put in the process thing in front of R and then click enter?
Yeah, Control Enter.
For line
Control Enter. So look, you have here a tab. You are on this tab. Here you can change your tab. You go back to the script. You have a chart open, which is from a previous example. You close this, and you go back to the script. Basically, gets you back to the script.
Opening in R Studio, in R.
You need to go in R Studio and manually open.
Well, mine also opened in R.
Yeah, you need to open it from R Studio. Yes.
So you should accept the chart.
The chart, you don't need the chart. Don't worry about the chart.
Just
This
check
is,
it out.
yeah, you need, yeah, you can close it again.
Can I come up with it?
Wait, are we, which one am I supposed to be in?
Hmm?
This?
Yeah. You are,
Here's our studio, but this is not open, I think, and this is our console.
Yeah, you need to open your. You don't need this. Close this. Don't save. And open here your practice lab. Was open file. Find the practice lab that you downloaded. You are also in R. You need R Studio.
Well, it doesn't come up like
So you need to close it. Close this. Don't save.
This also closed.
Close. Don't save. Now go on our studio file open. Okay, once again, everybody. Excuse me. Yep, you need to manually open this file to get it in our studio if it automatically opens in R. We tried to remedy this in the first session, but okay, so you have our studio open, you go on file, open, and then you find it wherever you downloaded it. You likely have it in the downloads folder, which is to be found right here. Yep. You have Windows, you have it also in the downloads folder, but yours look different. You have it? Yeah, don't worry. Just open it in addition to that. Don't worry about it. Okay. That makes it better. Yeah? Or open a folder, as I suggested. I would open a folder that is labeled like the course. Yeah. Okay. So we're running now line number 2. We're emptying the environment. We're running next line 6, which is essentially opening exactly this data that you have in your Excel.
If you go to line 6, press Command Enter.
Control Enter.
I can't get my thing on my job. I can't get it open.
Have you downloaded it?
Yeah.
Just go on open file and open it there. No? No? So you can come here if you want. Yeah.
It's not going to the desktop. Oh, no, obvious.
Good. Demonstration effect successful. Okay, good. We're running now line 6. We only have 20 minutes left. I would hate for you to have to do it alone. So line 6. We're running and opening now here an object, and this object contains the same data as you have in Excel. Once you have this open, control line 6.
Okay, now mine's a chart.
Go back to the script, don't go in the chart.
I can't. Oh, well.
Good. Okay, line 6 creates the object. As you see, it's again the data frame code with just this bunch of numbers that you already have in Excel. If you click now on line 12 and you run line 12, you get a t-test computed for you, which essentially contains all the information that we have now calculated in several cells and several calculations. R does this all for you. R calculates your t, gives you a degree of freedom, gives you a p-value, gives you differences, 95% confidence interval, all the information is there. Yeah? No. No. Yes.
Yeah, you go back. I can't go back, right, on R?
Yes, you can go back.
Mine just all blue. There's no like black on the bottom. Yeah.
How do you go back?
You run line 2 first.
Yeah. Should I try again? I did
Try again.
one line 2, then line 6. You just press backspace.
No, don't press backspace.
I can't do it. This is so
What is this? What am I looking at?
Did I run the wrong one?
Are you here in lab 3?
Yeah.
Lab 3. You run this.
I did.
You got this. Oh, you don't have the solution open. You gotta download the solution from Canvas. From Canvas. Yes.
Why does mine look like this? It doesn't look like yours. Mine is like blue at the bottom.
Okay, everybody download the solution, please, from Canvas.
How do you find the solution?
By going on Canvas. So you have on Canvas, you have Practice Lab 3 solutions. That's why yours looks different than mine. Because you got just go on module 17, there's Practice Lab 3 solution.r.
So I have to just run it again.
Yep.
I don't have to re-download it, right?
You need to download it and you need to open it in RStudio, yes.
I did that already.
Okay, then you're fine. Then you're fine.
Oh, no, isn't that what we just did, or I should do it again? Or I did that already?
No, you need to restart it with running the solution, right?
I should click that?
If
Yeah.
ours look like.
No, you
yours-
need to download it and open it in R.
If ours look like yours, we don't need to change it, right?
Excuse me?
If ours look like yours, then we don't need to change it, right?
No, it's fine. If you have the solution spreadsheet, you're fine.
Oh, yeah.
Yeah.
Mine also looks like yours, so I'm not gonna do that.
Yeah, you just need to run it
Rerun.
one by one. Okay, who has still problems? Yes, Naomi. What's the problem?
It's not funny. Like, nothing happens when I hit enter on the lock, except that it actually ends.
Control Enter.
Yeah.
All right? Good. Next. Okay, Control Enter runs each line. You run line 2, then you run line 6, you get the data frame. You go on line 14, will now load your t-test into an object.
Should I run
We
mine?
control under it.
You run the same thing on line 14. Then you can write in, just press an enter after line 14, go on line 15 and write this t-test object here. Just write it down there because that's how you can address the entire t-test.
You just designed this, you know, stuff?
I just wrote it again once here in line 15.
Instead of solutioners?
Yeah, because this here, you remember the type? This basically fits this function into this object. And this object becomes now an object here. Hmm? Yeah, and then you can call it. So with this line 15, you call your object. And it shows you the entire object now.
I ran 15. Is that fine?
Oh, it's fun, yeah. You can press, did you run that?
Now I did it the right way. I
Okay.
didn't Run that. I didn't-
No, that's fun, that's fun, that's
I
fun.
run-
Yes, Sarah. Oh, God, sorry. So, forgive me. Oh, my God. You're so far away. Okay, what error? Yeah, you need to run the t-test first. You need to run line 14 first.
And then you run.
Yep, and then 15. Then you need to start from scratch again, but don't change anything that I wrote. Control Enter from top. Line 2, line 6, line 14. Yes.
You said line 2, line 6, line 14? Oh, 12, right?
12. No, you don't need 12. You can just run 14. Yep. Show me.
This looks right.
Okay, line 2, line 6, line 14. There we go.
Is it good now?
That's it. You just gotta run one line after another. That code, as I given it to you, runs alone. You don't need to do anything. So there's no way this is not working. What?
Did you run line 15?
I entered line 15. And this is now t-test df1. And that gives you the result of the t-test.
Did you have to run it for
You need to know it. No, you need to run it. Don't shy away from running stuff. It's like it gives an air. No, seriously. No. It's even if you run it and it gives you an error, it's not a problem. This thing is not exploding in front of you. It's like nothing will gonna happen. Nothing is gonna happen. These codes that I give to you, this is a playground. This is like a sandbox. And you use it or you don't use it, but it's super simple. It's super self-explanatory. If you want to learn it, you just go through each step of these, and you will see. Okay, so the reason why I packed this into an object is because with LSDF1, you see a list of what is contained in your data frame, which is 2 variables. And if I do LSDF1, this is all the information I can get out from my t-test object.
Mine says 159 out 16.
I'm not sure what you mean.
Like where it says in brackets 1 and 6. Yeah.
I don't see that. What do you mean? 1, 6?
Oh, mine doesn't say 6.
Yeah, mine says 12.
Okay, all right, we need to carry on. Please run the code exactly as I provided it to you. It will yield the right results. Okay, example 2. Consider the following data, score 1, score 2, same thing, paired sample t-statistics. We know already how to do that. We only need differences. We just use the same code, the same approach as we used in example 1. You just calculate the difference, you calculate an average. And you get again an average, right? So what's the main point of the exercise in R is because all the values that you have derived in Excel are now also calculated in R. And these are the codes for you to get these. So you have with line 20, you have a confidence interval, and with line C, you get your effect size. That was all that this code is actually doing. So now if you go in Excel, back to Excel, example 2, will essentially allow you now to calculate the difference, again, the average difference. So this time score decreased. So what are we doing? We need in part A of this endeavor, we need the standard deviation, right? So standard deviation is essentially STDEF again. So it's the same exercise. We get a STDEF, now we do an SEM, which is now the standard deviation, divided by square root of 5. That's as a standard error of the mean.
Can you go back to standard deviation? If you go back to standard deviation. Can you now go back to standard?
So it's C4 to C8. The critical value is 2.78. Critical value of 2.78. 2.78. To where? SEM is standard deviation divided by square root of 5. Yep.
How do you get the standard deviation again?
STDEF, C4 to C8.
Okay, thank you.
Sure. Now the calculation of a t-score is essentially now your difference divided by the standard error of the mean, as we know.
Wait, how do you get the critical value?
By reading it in the t-score table. T-score table.
When you divide the t-score,
Hmm?
the t-score, it's C10 divided by
The t-score is C10 divided by H5. Yep. So the t is now minus 2.8. Are we rejecting or are we not rejecting?
We divide by what?
T-score table. You're the expert of the T-score table from now.
No.
Okay, so it's 2.84. Are we rejecting or not? Nope. Yes. So it's exceeding our critical value because it's a two-sided test. It's minus 2.78 and plus 2.78. So we're rejecting at an alpha level of 5%. 5%. Good. So this is now our T statistic. Now we need a 95% CI, and that we know already in and out. Lower limit, upper limit. So we're calculating the lower limit now was minus 7.8 minus critical value 2.78 multiplied by the standard error of the mean. This is minus 15. Now we're doing upper limit plus 2.78 multiplied by standard error of the mean, minus 0.16. Yep. It's the mean minus the critical value multiplied by the standard error of the mean.
And then the other one just plus instead of minus.
Correct. Yes,
I did what you did, but I got a very different number.
that's a problem.
Would you do the upper that show you?
C10.
What did you do? Oh, in red.
I'm on the wrong one.
Yes,
Hold on.
you did critical value multiplied by
Oh,
SCM.
this.
Yep, you need, yep.
Upper level?
Well, it's the same formula, right?
Oh, I
You're adding it in rather than subtracting it. Sure.
So for lower limit, it's always minus. Wait.
No, yes. So minus 15 is smaller than minus 0.1, right? So we have now an effect size to calculate, which is C, which is now difference divided by the standard deviation, which is an effect size of minus 1.3, which we know is greater than 0.8. Thus is a large effect size. You're welcome. Okay, now we do the same exercise in R. We go on line 25.
Control enter.
Control 25, enter. So now you run line 25, which includes 25 and 26. You press Control Enter anywhere in line 25, it will automatically run both lines. Make sure that you didn't select anything because then it runs only that fragment. So blinking cursor and then Control Enter runs the whole thing. Now we do t-test df2. That's for me, it's line 31. And if you now press an enter again for line 32, you can now copy this down and you get your entire t-test here spelled out.
Should we run 32?
You need to create 32 first.
And then
You need to just calculate, just forget everything below that because that's the function.
Yeah.
Just the object, run the object alone.
Okay.
You will get the entire t-test here spelled out. That is your p-value. That's your degrees of freedom. Run it again from the beginning. From, no, just from 10.2, from the example beginning.
So what's the first thing you have to write?
Yeah?
What's the first thing you have to write?
The data frame line. This one. 25. That builds the data frame, and then you run a t-test on line 31. You run a t-test. You pack it in an object, you start the object, and this will show you the entire t-test. You're welcome.
Mine, I did it right, but when I press enter, it says.
Control enter, I hope.
T-test.
Control enter.
Yeah, it's like,
Okay.
it pressed error object, t-test, TF2 not found.
Then you need to rerun the data frame code. That's on line 25.
Okay, so press enter,
Control enter.
control enter, and then enter 27, 28, 29 also.
Yeah. Just run everything through. It will automatically run it.
Okay.
That's the beauty of this code, right? You just need to run it through. Okay, so these are exactly the same numbers as we have found with Excel. And now it's getting a little bit more complicated. Now we're going to do an independent sample t-test. But this time, so we do all the 6 steps. So please do those 6 steps. For the sake of time, we're not going to do the six steps. But we're calculating now a t-test in Excel. So t-test in Excel is t.test. T.test with 4 different entries it requires you to give. It wants array 1, which is sample 1, array 2, which is sample 2, tails 2, type. This is where it's getting interesting. We're clicking here now the formula builder, the fx over here. We click on array 1. That's our TV fiction. Array 2, documentary. Tails 2, type. And now you need to read what's written down there. So we have type. In this kind of t-test, a paired t-test equals 1. So if you are dealing with a paired t-test, you need to type a 1 here. We know it's an independent sample t-test. So if we have a 2 sample with equal variance, a so-called homoscedastic t-test, we would do 2. However, if it's a 2 sample t-test with an unequal variance, aka Welk's test, we're going to do 3. And this is what we're going to do. Reason for that is, you remember how we did the aliquots, right? We aliquoted the variability to each group based on their sample size. This is what this means. If your variance is different between both samples, you need to use 3. You need to assume an unequal variance. There are only rare exceptions where you assume equal variance. So 3. Then you press done, and that gives you p-value. And this p-value here is 0.0369 something p-value. State in your own words what you learn from this confidence. Okay, confidence interval is, well, we know, SD. Okay, let's get this one out. Let's do this now. Okay, so this is the p-value. Now we want to do the same example here in R. We go on line 40. We get means. We get standard deviations. And we get now a t-test. And that t-test gives us now a p-value, which is consistent with the one we have, gives us degrees of freedom. It gives us t-scores, and it gives us 95% confidence interval. What do we learn from this 95% confidence interval? As per the questions. We know the null hypothesis. We're testing against the mean difference of 0, right? Yes.
But you ran 40 and then which one did you run after that?
All down to 56.
Everything one?
Control enter, just go systematically through. The only thing I want to see in Excel is the p-value. Don't worry about it. Just write out the 6 steps of hypothesis testing, what the null hypothesis is. Do that, please. But don't worry about the calculation of the confidence interval. So we need to get now to this. So when you look at this 95% confidence interval, what's your conclusion? It doesn't contain 0. So it needs to be significant. Keep that in mind. 722. All right. Any questions? Yes.
Are we, 2 questions.
Yes.
Are we submitting Excel or just R?
Please submit Excel. Please do the 6 steps of hypothesis testing. You don't need to do the independent sample t-test by hand for the confidence intervals, not necessary. I want the p-value and the 6 steps of hypothesis testing, please. Okay, rest of this is good in R.
How do you submit R? You want the R? Can you show us again how we should submit it?
Yes, there was actually also a request from the other groups. Okay, we go on Spotlight, which is here on the right, that little magnifying glass. You go on Text Edit. Magnifying glass, right top. For those of you that don't use Spotlight, you can call any application. You just create in your folder, make a right click, go New. Will also give you a new text document.
Wait, what are you supposed to type in?
Naomi,
Open up, just a random one,
just open a new text document, change the name.
like Word?
No, text document. Just make a right click anywhere on a folder. And you will have new, or do you have German, right? Neues text document.
Don't you need to save it?
Yeah.
Don't you need to save it first?
You can save it first, or you can save it after.
I don't see it in text edit.
Yeah, I don't see it in text edit.
If you do text edit, you have new document.
Oh, okay.
Yeah. You open a new document, you get this.
Yeah.
Yep. And now you can save it. You can save. And you go in the folder where you want to save it, which would be Practice Lab 3.
Yeah.
And then you label it with your name.
Let's submit each separately.
Practice Lab 3, your name, and the course number. STAT1021 G.
So if I open the notes,
You run the entire code. Okay.
Yeah.
So you basically, you go, just like with Practice Lab 1, you go on the left lower quadrant, you press Control and L. That empties everything in the output. Now you go on the left upper quadrant, don't despair, don't despair. Go in the left upper quadrant, press Control and A, and now press Control and Enter.
where do you submit it on L?
Now for the submission. Yeah, you can order
Wait,
this.
can you run through that again, please?
Okay.
We should delete everything we just did.
Control L on the left lower quadrant.
Yeah.
Left upper quadrant, Control or Command A, depending on whether you're Mac or on Windows. Yep. And then Control Enter
Where? We're gonna control enter.
in the
And
script.
then we copy and paste the bottom into text edit.
Exactly. And then you copy the whole thing into the text edit and you save it. And you submit it together with the Excel.
Can you show me?
Yes, please.
I don't know, whatever you should do.
Yeah, me too, so I'll just watch.
Control L.
Yeah, it wasn't doing that for me. Oh, it's supposed to Command L.
Ah.
And
Now
now,
you press Command A
yeah,
and Control Enter.
and now it's right there.
Oh, didn't do it. Oh, that's interesting.
Is that it?
Yeah. Oh, that's interesting. Oh, no. How did you do that, Emma? Clearly. No, but that's interesting.
No, what do we do?
That is very interesting.
You just know I did it. And like,
No, absolutely not. Okay. It's congruent. Where did you save your practice lab? Oh, here, that's good. Okay, file, where's the practice lab?
oh,
Practice lab, here, solution. Okay, good. There are no such file. Where did you save it?
I don't know, in like my downloads or
Downloads?
something.
Okay. Thank you.
Yeah, here.
Here, practice lab 3 solution, practice lab 3 solution. There we go.
That's
Okay.
it?
Yeah, that's it. Control A, Control Enter.
And now I can submit it?
Yeah, you select this whole thing, you copy it in a text file,
What's
and you submit that
What's
with the Excel. With
What's
the
the
Excel.
text file?
Spotlight. You open it,
I have Spotlight
text
here.
edit. Yeah,
Yeah,
yeah. Open one of these.
this?
Yeah.
Oh, it's this.
No,
This is
not this.
Practice Lab 1. These are all Practice Labs 1.
Yeah, yeah. Now you need a new one.
How do I get a new one?
If I open this on the left.
Like this? Is this what it's supposed to look like?
Wait,
So,
that's not happening for me.
Yeah.
How do I?
I just copied and
You
pasted
go
the
on
bottom.
text edit,
Did you?
And now,
new document.
and then paste that.
But the
Paste
bottom,
it
the
here.
bottom part, not the
Okay.
top part, right?
Okay,
With the bottom part, right?
with the bottom button.
I didn't do that.
Teachers 2 not found. Interesting. Oh,
I can just command that.
okay. Okay.
It needs in the top and the bottom.
So that was changed to 1 rather than 2. Yeah.
Do we need
I will.
it's just the bottom, right? Like this is fine.
Yes,
Now I gotta submit it.
with the Excel.
Can I just do this? Can I submit it separately?
Yeah, you can upload those. Yeah.
Am I supposed to put this onto the
Yeah, exactly. You put this in a text document.
was it? Maybe I want Command L.
No, this one you need to select by hand. You need to just, yeah, you need to do this. Yes. Perfect. All right. Yes.
Hopefully, no, I came late because I live downtown.
Oh, okay.
So the trains were delayed.
It's fine. Okay, thank you.
Thank you.
All right.
Okay, wait, once I'm, I did code, control L, what do I do here?
Well, then you run it. You control enter.
Oh, here.
Control enter?
Yep.
Oh, that's it? So now
That's
how do I
it.
get
Now you
this?
copy this in a text edit file.
So-
Text
Where
file.
did you hit Control Enter?
By selecting the entire script.
Okay. There, I think I got this.
Why is it not highlighting it?
I think I got it.
Oh, wait,
Yep.
why
Yeah.
is that so small?
We good?
I thought the 6, this one, I'm supposed to do this, and it's fine.
Yeah, difference. Yeah, difference is good.
What do I do because this one's extra one? Or it doesn't matter? Or do I get 29?
Yeah.
No, well, if you want to calculate, so you don't, I just need the p-value. I just want the p-value. If you want to do confidence interval, you need to do it like we did it in the lab, in the class. It's more complicated because you need the pooled variance, you need to calculate the standard error of the
So you
mean.
don't want that?
Well, I would love that.
This is what comes.
If-
You know what I'm saying?
No, well, it's extra work,
It's just this, and then.
Yep. So lower limit would require for you to calculate the pooled variance.
Okay, thank you.
But you don't
Not
want, you don't want that?
It's-
You
it's-
just
This
want
is correct?
P-value is fine. Thank you.
This is what you want, right?
Yeah.
Okay, and then for the Excel, so for these, for the first two, we did like the difference and then the ABC steps.
Yes, yes, yes.
For the second one, so what do you want now for the
Just the
third one?
p-value, the p-value with this t-test formula.
That's
Yeah.
all you want?
That's all you
Yeah.
want? We don't need to do the difference?
Well, no, it's fine. You have it in R.
Should we
What we
answer
need
the
to
question?
Yes, yes, yes.
Like, are there questions that we should answer about that? And just for the last.
Yes, the 6 steps of hypothesis testing. Oh, yeah, excuse me, the 6 steps of hypothesis testing.
What do you
Oh.
think?
I did all
Yeah.
those 6 steps.
Yeah.
No, I think I did something wrong. with-
No, the 6 steps,
You said you don't calculate the.
no, but the 6 steps still we need, right?
Like you
The
want.
p-value, forget about the t-score, we have the t-score from R. But I still want you to write it in,
Like basically just write out what the 6 steps are.
yes,
It's on the slide.
just, yeah.
Oh.
Just go step by step.
We have to list them?
Yep.
Oh.
Oh, no, Matt, you just want us to write, step 1, do this, step 2, do that, 3.
No, just go step by step through the example, right?
Oh,
So the example, develop a null hypothesis and state the null hypothesis.
Oh,
Okay,
okay, fine,
Yeah.
okay. I think I did something wrong with this. I did the intro, the control L, and then I did, and then I command A, everything, and then I hit like,
Yeah, now you need to select this by hand.
But is this, why is it so small compared to?
I don't know. You can zoom in with doing
Can
this.
I think it's, I feel like I put something in wrong.
That,
Can I
don't know.
delete this? Or is this
Yes, with Control L, you can delete it.
Control L?
Yep.
Okay, and then, oh,
Control L, you press Command L.
oh. Okay,
Yep.
so do you mind just showing me again how to do this?
You just press Command A,
Here?
Command A,
Here's A. and
Control
then
Enter,
Control, enter. Oh, and then copy and paste this into text.
correct.
Thank you so much for that.
You're welcome.
I'm confused.
You're confused,
Don't
that's
want
okay.
it to calculate it. Can you, because okay, like for.
No,
D,
the 6 steps of hypothesis testing.
Like what we did on the PowerPoint,
Yes,
like this.
so you just characterize the
We have to-
comparison
we want to
distribution.
actually find the answers for all the six steps?
Well, you have the answers from R.
Yeah, that's what I was saying, so you just write the answers from R.
Just fill it out accordingly
Oh.
with the results from R.
Do we have to do like the functions? Did you hear that? No, he just wants. the
No, you
answer.
just run what you
Like,
have
do
from
this.
R.
You basically, you want this, not this, right?
Exactly, the 6 steps. yeah.
Yeah, and then you find answers in this.
From R,
From
yeah.
R, okay, fine.
You have T, you have P, you have everything.
Okay,
Yeah.
and we already found the p-value, right? Okay,
Yeah.
fine.
Yes, exactly. But you also need a T,
T
right?
is this, T is this, and then you.
Correct. So your
T
T
is,
is
and then the confidence interval is this, the upper and lower.
correct.
And the
Yes.
95%.
Yes, yeah.
Okay.
Sure.
Okay, I have questions for the homework. Is it okay that I did it on paper? And I did
Sure.
my calculations on paper?
Sure.
Okay, fine. And then, for the tables, if it doesn't say the significance, I assume that it's 0.05.
5%, yeah.
So I wrote assuming 0.5 significance level.
Okay, that's
Okay,
perfect.
that's fine. Okay, and then also,
Are you doing a set score?
I did the, no, the singles, I did the tables.
Do we need a set score or do we need a T score?
Z-score.
Okay.
Okay, fine. And then, for this one, it was unclear in the wording. Is it after minus before or before minus, like? is
It's
it-
the same thing. As long as the significance testing is correct, it's just the interpretation, right?
But because if I do it the other way, then it would be a negative. It's supposed to be a positive, or does it matter?
As long as you don't mix up the interpretation, it doesn't matter.
So it doesn't, so is it fine either way?
It's fine either way, but the interpretation needs to be correct, right? You need to understand, okay, so it increased from before to after, or it decreased from
Wait, so how am I supposed to know?
the way you're calculating it. So if you have if you have a higher level and you have a lower level on the second observation, you had a decrease, right? But if you have a calculation where you calculate before minus after, this increase is actually increase. So it's a positive number, although you're describing a decrease. That's the reason why after minus before is more intuitive.
So then if it's after minus before, then I would do it how I did it here, right?
I don't know the example by hand. But mean before is 18.4. Mean after is 20.45. So yeah, that's an increase. You did before and you did after minus before. You did it right. Yeah?
Oh, so that's fine.
You did it more intuitive. If you would do it the other way around, it's still okay. It's still correct, right?
Okay, fine.
Because it doesn't make a difference whether it's positive or negative. It's just more intuitive to have something that is decreasing with a negative sign.
Okay, fine.
It's just you helping yourself because down the road you may mix up, right?
Wait, is that the homework?
Yeah,
That's
I'll
it.
homework with Excel. You can do it on paper.
No, you can do it. In
Also, for
you can do it in R.
I could do that on paper.
Yeah.
And you would count that?
Yeah.
But Excel's easier now.
Also,
so much easier.
for, guys, sorry, shut up. I didn't think. What was I gonna say?
Are we better than the other class?
Huh?
Are we better than the other class?
I don't do favoritism.
Oh, for the average, do you, like, I did that, I calculated the average, like, by myself. I didn't show you the work how I calculated.
No,
the
no, no.
average.
This is we're past that stage.
Oh, here.
Yeah, okay, so it's just-
Yeah, yeah, that's fine.
Okay,
That's
fine.
fine.
Thank you.
You're
Okay, I need help with the 6 steps.
all right.
So I have the p-value, then what's, do I need to do the difference?
The difference between what and what?
Wait, also look, I color coded it. I just thought
She
that,
wants to go into computer design, but she's not going to.
okay,
Why not?
because I'm scared.
Oh, what? Don't be scared.
Okay, so wait, what do I do next?
6 steps. But what are we supposed to put in for the 6 steps?
The 6 steps are over here in
Yeah, you
Canvas.
have that in PowerPoint, right?
Yeah, I just need to get
On
to
the
it.
slide.
Oh, but I don't want to go out of this because I'm in the middle of submitting. Can you go on it?
Yeah, but which PowerPoint is it?
Oh, the submitting takes like 30 seconds.
This is the all have, I just don't know what.
These 6 steps, right?
So just copy and paste it?
No, we have to answer all of it. So
Mhm.
now I write step 1, right?
Hmm?
I would
First step one is
identify
identify the population.
Okay, one after another. What?
Identifying the population.
Yes. What are the population?
Would it just be the? Oh, it would be the, wait.
It would be the document, it would be the.
I'm just trying to force you to read the question, right? Because that is the training here.
Oh, it's the.
Because the more of these questions you read, the less likely you're gonna encounter one of the quiz that you don't right away just click, like understand.
People who
No,
watch
but
the
that's-
work when they
Yeah.
fictional television. show. That's
Like
it.
imagine.
That's the population?
That's step 1.
But define it. Define the dependent variable and the independent variable.
This is a cool test for fiction on television. Fictional. Okay. Then, when you want it to independent and dependent,
Yes.
and that's it?
Well, that's step 1, right?
Yeah, for step 1. Okay, so independent variable.
And what's the comparison distribution?
Um, Is it high, is it fiction and then a documentary?
No, the comparison distribution, that's the distribution
What's the?
of the differences between means, right? Of the-
Independent. Or dependent
No,
variable.
yes, so we need a dependent and independent variable. So the dependent is the type of show they're watching.
So that would be the fictional,
That is independent. Independent is what defines the grouping.
that would be fictional. And then documentaries, right?
Those are the two independent variables. So it's either or. It's the type of show. That would be the greater type of variable that you're looking at.
Okay. Oh, and then it would be